Hello, and welcome to the professional development on how to teach computational thinking using a fun program called Scratch. You will learn some basics about what computational thinking is, why it is an important skill for students to learn, and how using Scratch can get your students thinking like computer scientists to solve problems in many different areas of curriculum. The objectives for today's professional development are to understand what computational thinking is and why you should be teaching it, to get an overview of Scratch and learn some basic coding and how you can use it, to understand that coding is not just a skill to be used for computers, but is an important literacy skill that can be used across the curriculum. And you'll get a chance to play around with Scratch and to create a dance break animation to take back to your classroom for both you and your students to use. Let's go. So the first question is, what is computational thinking? Well, computational thinking is a set of problem-solving skills learned most often through computing and coding. This does not mean it is the only place that it can be used, but we call it computational thinking because it is similar to how a computer works through problems. It is a skill set that is held by a lot of computer scientists, but it can also be learned and used by anyone in any field of work. It is a way to break down a larger problem into smaller, more manageable parts, and it teaches learners how to solve practical problems. According to the Google course for educators on computational thinking, it can be used anytime you want to develop a problem or algorithm to solve a problem. Computational thinking is best learned through the process of computing and coding because it teaches learners the way in which computers think, breaking down parts, recognizing patterns, and creating algorithms. This means that learning computational thinking can be applied in many different subject areas. So what are the steps of computational thinking? The steps of computational thinking are the same ways in which a computer thinks. You have decomposition, pattern recognition, abstraction, and algorithmic design. The first one, decomposition, is a very important skill. And it's the process of breaking down a larger problem into much smaller, more manageable parts. Students learn how to do this when they are solving multiple step word problems. For example, students often have to solve word problems that say something like, D started with 10 apples. She then went to the store and bought 2 more bags of apples that have 8 apples in each. How many does she have now? Now, as we know, many younger students struggle with this, breaking down the huge problem into much smaller, more manageable parts. And learning how to be computational thinkers allows them to see, oh, there's 2 parts to this that I need to do and then solve. It is an important skill that students need, and we need as well. The New York Times article that is listed as a resource at the end pointed out that we even do this when we compartmentalize our grocery list, when we categorize our grocery list into produce and dairy and meat and canned goods and dried goods and frozen. Hey, we're breaking a huge problem, making that list into much more manageable steps. Pattern recognition is the second. And pattern recognition is the ability to see how a current problem relates to a previously solved problem. Students oftentimes come to a problem that, sure, they've done something similar to it before, but as soon as they see it, they stop. And learning computational thinking allows them to look at a problem and say, I did something like this earlier, and I could probably use it to solve this problem. When students are programming, they learn how to see a solution they used earlier and how it might work to write the very next step, or how only part of it needs to be changed or modified or refined in order to solve the particular problem. Abstraction is the third step to computational thinking. Abstraction is the ability to set aside information that isn't needed. So being able to look at all of these steps, 1, 2, 3, and 4, and saying, I don't really need information for problem 2. We teach our students to do this when they're reading, to say, I don't really need this information to answer this question. We do the same thing in word problems just like this. Oftentimes there's information that isn't needed, and they need to know how to set that information aside. The next thing we have is, the next step is algorithmic design. And algorithmic design is creating the steps to solving a problem. So once we've broken our problem down into parts, students have to be able to come up with the steps that are required in order to solve the problem. This is the creative part of computational thinking. It is the fun part. It's where students are allowed to think outside of the box and come up with ways to solve a problem. It is creative and unique in its way, because just like if you want to get to the grocery store, here's A and here's the grocery store, you might have to go this way or you might have to go this way. But either way, you're going to get to the same destination. So the steps of algorithmic design and the ability to refine the steps allow students to come to the best outcome to solve the problem. So as we stated earlier, computational thinking is important in many areas of curriculum. And as you can see from this chart found on the Google course about computational thinking, these computational thinking skills are important because they transfer to other areas of learning. For example, when students learn to break a problem into parts or steps, this can transfer over into literature. Students can look at poems and be able to analyze poems down into meter, rhyme, imagery, structure, tone, diction, meaning. And even earlier than learning how to break down poetry, we teach our students the elements of a story. So being able to find the plot and the characters and be able to tell the setting, being able to find theme, the climax, the resolution to a story. Practice with computational thinking allows your students the ability to break these things down better in other areas. When students learn how to recognize patterns, they are better equipped to find solutions to problems where similar problems have arisen before. For example, in economics, being able to find a cycle pattern in the rise and drop of the country's economy, or being able to see relationships between how plants grow. Your students might be doing an experiment where they're learning what's the best amount of water, the best sunlight is required for a specific plant. And maybe they've done something earlier that was a similar type of plant, or they've read something earlier about a specific kind of plant. And they can take that information and see patterns to apply it to their new problem. When students develop instructions to solve a problem or steps for a task, this can be used when doing expository writing. We get our elementary students started very early in writing the steps in how to solve a problem. So writing a recipe, or even simply writing the steps to a science problem. When students learn to generalize patterns and trends into rules, this part of computational thinking gives them the ability to apply those rules in other places. For example, they might learn that to figure out that the rules for factoring second order polynomials, that never changes, that from problem to problem, you will always use this. The same thing in chemistry, determining the rules for chemical bonding and interactions and using those are important. They can apply that to other problems that they are doing. So why exactly is computational thinking important? Well, the Innovative Pedagogy article that we read states that researchers who have investigated how children engage with the programming environment of Scratch have identified skills and shifts in perspective related to computational thinking. Some of these include the confidence and persistence in experimenting with complex problems. In my experience as an elementary teacher, I have often found that students get very frustrated. They get very frustrated and lose focus when presented with problems that require numerous steps. They can easily solve problems that require one, but when you get into them where they require 5 or more steps, they get really frustrated and they lose their confidence. So when students have more practice with the steps involved in computational thinking, they become more confident in their ability to break down big problems and are more likely to stick with it until the problem is solved. According to the New York Times article, kindergartners who had learned how to use Scratch were able to describe 15 to 20 steps to describe how to brush their teeth, where before being introduced to the program, they could only give 2 or 3 steps. That's a big difference. Computational thinking also builds on and reuses prior knowledge. They can make connections within specific subject areas or even from without the subject area and apply them to solving problems. Students are also better able to think abstractly or outside the box and modularize steps better. Computational thinking allows students how to deal with open-ended problems and how to connect and communicate with others better. They learn the power of communicating their ideas and learning from others and how they can use the steps of computational thinking to solve problems that actually help others as well. It also gives the students the ability to ask more questions. They feel empowered to ask questions about the world. So the fun part, what is Scratch? Scratch is a great problem that teaches your students how to become computational thinkers. There are a few different ways to teach computational thinking, but we are going to focus on the specific program called Scratch. Scratch is a free program that allows students and teachers to code their very own animations, which I'm going to show you very soon. Now, this could be an animation that tells the part of a story. You could have your students, set up a scene where they're telling the story of the 3 little pigs, and one kid tells the story of the first pig, and another kid tells the story of the third pig, or the second pig, and the third person tells the story of the third pig. It could also be used to make games, to practice math facts. It could be an interactive map. Here's my awful illustration of Florida. And students can create something where if you click on a specific area, it will tell you information about that area on a map. The ideas for Scratch are endless, as you are going to see. It also teaches collaboration, design, problem solving, computer literacy, and the steps to computational thinking. Students have to use these bars of code. Okay, as you can see right here, each of these is a different piece of code. They use these to allow their character to talk, move, or perform a specific action. If they want their character to move 10 paces this way and back 10 paces this way, then they use the bars here to code that specific character to do the steps. They can do this together or they can do it alone. But either way, they are learning to think a lot like computer scientists to solve problems. Now, the program is designed for students aged 8 to 16, but it is being used by everyone. As you will see, it is a lot of fun. Coding is often very complicated and contains these long streams of code that I'm sure many of you have seen that is very confusing. And it's definitely confusing for students. And this is a great place for them to start because it gets rid of that confusion and it puts it into these buttons. Okay, so this stands for a specific piece of code that they only need to use that piece to tell it what to do. So let's go take a look. at the Scratch website. I'm going to talk for about 5 minutes, then I'm going to let you go and play around and get your hands on what Scratch is all about. So this is the main Scratch website, and the first page gives that opening video that I showed you, and it shows you some featured projects. There are areas up here. You can join Scratch. You can create your own account if you want to save your project. It doesn't take much. There's a help area for anything you want to learn how to do. There's an area that tells you more about Scratch that you can look into. Something I'd like you to check out, at least go to once, is the info for educators. It is a whole other area called Scratch for Educators, and it's a great resource to find other teachers who are using Scratch. There's a lot of articles, scholarly articles. There's this TED Talk here that you can see. And there's lots of different resources and things that your students can either use and add to, or ideas for you how to teach lessons for your students to use Scratch. There is a discussion forum you can come to. There is also an area where you can get already made Scratch projects. You can find games, you can find just silly animations, and you can peruse by going through, find games or things that have to do with music, stories, and other tutorials. But the fun part is the Create tab, and the Create tab is where the magic happens. It's where you will design your animations. And this is what it looks like. You have an area over here that gives you tutorials on how to use Scratch. If you're ever in doubt and you're not sure how to use something, this is the perfect place to go. When I first learned, this is how I started. I learned how to use it through getting started with Scratch. And there are plenty of other how to make a birthday card, animate your name, make it fly, and they all show you step by step. It's really easy. There's how-tos over here, every single one of the effects. Or you can find out what each one of the blocks do. For example, you want to understand what move 10 steps means, it will tell you right here. And for using computational thinking, this is a great resource for your students. When they're unsure how to solve a problem, have them go here. They will look at the help, it will tell them what to do, and they can apply that information in many different areas. That is the experience that I have found. So as far as your working space goes, your sprites are the characters that you can use, and it will always start you out with this little guy. But you can get other sprites from here. And there's all different kinds of people, animals, lots of different things. And each character has different costumes, for example. So for example, I could click Casey and it tells me that she has 4 different moves or 4 different costumes. So when I click on her and if I click costumes, it shows me the 4 different things that she can do. And students can animate for her to move in between those things. So here's your area. You've got your sprites. You can also create your own sprite. Students might want to make their own. They can draw in here. And there we go. You already have a sprite. So this is the area. These are the specific pieces of code that tell your characters what to do. So for example, I want my sprite to turn 15 degrees. And I click on it. This is what it will do. There's a lot more to it than that, but these are the pieces of code that will tell your character what to do. There are looks, there's sound, which we'll get into later. You can make the characters draw lines on the page. The events tell when the characters will do things. This is control. This is another important button we're learning about. And then there's sensing and operating. Okay, now it's your turn. I want you to pause this video. Please pause it. Take no more than 10 minutes and go play around with Scratch. The link is located below this video. Now, while you're perusing and playing, I want you to be sure to be thinking or writing down different ways that Scratch is being used by students and teachers. I also want you to think of some ideas or ways that you could use Scratch in your own classroom. And of course, write down any questions you may have as now. You can post your questions on the video chat below the video. So I hope you found some great ideas and you're already thinking of ways that this program could be used by your students in the classroom. And if you have any questions, there's a chance I might answer it while we're working, or if not, please leave your questions in the chat and I will answer you as soon as possible. So I'm going to show you some of the basics of Scratch. As stated in the objectives, at the end you'll be able to create your own dance party to take back to your classroom and also to teach your students how to make on their own. And you can adjust this to the level of your students depending on where they are. They can do something as simple as moving one character from one spot to the next, or they can do something as complicated as moving and turning and talking and dancing. That's up to you and your students. I myself use these particular dance parties. I make them and use them in my ESL classroom because my kids need breaks, and so we do these little dance parties. So this is where the magic happens. I'm going to show you how to move, add some sounds, and change characters today. So let's start with the characters. In Scratch, we call these characters sprites. All right, and we find our sprites in the sprite library with this little guy. There's all kinds of different people, objects, things. I am going to choose somebody to dance in my party, in my dance party, and it's going to be this little dinosaur. Make sure the blue box is on him, and you can click OK. Now, I don't want this guy, this other guy, so I'm going to right-click on him and delete him. One of the first things I like to do is check out the costumes. This is where you can see how many different poses your character has. Not all of the characters have different poses. That doesn't mean they can't move or do things. They just can only stick to one particular pose. In this case, I actually only want this one pose. I want my dinosaur to stay in this position. So I'm going to make Dino move, turn, and glide, and then return to his original position. So the first thing I want him to do is I'm going to have him move. And here is where you can you choose what you want your character to do. So I'm going to program him to move 25 steps to the right. It now says 10. I want 25. If you want him to move to the left, you put a negative 25 because it works on an XY axis. Ding, 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 teachers. This is where your students can practice graphing as well. So I want him to move 25 steps to the right. So if I want to preview what that looks like, you can click on the button and it'll tell you exactly what to do, or it'll show you exactly what to do. Now, the next thing I want him to do is I want him to turn on his side. Now, you're going to put a wait in between and you can decide how long you want to wait. I usually do 1 second, so you can actually see the characters doing the movements. If you want it to be more seamless, then you don't need the wait, but in many cases you do. I want him to turn, so I'm going to pull out my turn in that particular direction, turn clockwise, and I want him to turn 90 degrees. Again, ding, 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 practicing rotation, practicing angles. Students get all kinds of math skills in here. I'm going to snap that right on. All right, and so I can preview it and it'll show me what it does. Move, wait, and turn. I want to get him back to his original position, so I'm going to do it again, and again, and again. All right. So now I want him to glide over here while he's on his side. All right, so to glide, we use this button right here. It says glide however many seconds you want it to take, and then your XY axis. Now, right now, these numbers are set to where he is. If I want to change those, I can type them in by putting the arrow over here and seeing that it's negative 211 and negative 100. But there's an easier way to do it. I can simply move him to here, and this automatically updates to where I want it to move, and that makes my job a whole lot easier. All right, again, we need to make sure we have that wait 1 second, and glide, and let's watch him move. Move, turn, glide. And there you have it. He has done what he needs to do. All right, now I want him to do this in a loop. And in order to do this in a loop, I have to get him back to his original position. All right, so to return him to his original position, what I do is I use that go to instead of glide to. And it will take him to that spot that I wanted. And let's see, where was it? It was about right there, right? So go to 117, negative 109. All right, and that will return him to that position. But I also want him to be upright. Right now, he is not upright. So we need to point him in the right direction. And point him in the 90 degrees right. It will put him exactly in the right position. We also need to put that wait 1 second in. And there we go. Let's see what happens. And he returns. He returns to that position. Well, let's watch again. And right back to where he started. And that's exactly what I want to happen. Now, I want this to happen over and over and over again. I don't want it to stop. So I need to put in a forever. All right, and this will allow it to continue over and over and over again. Woo! And he returns right back to that spot and glides and glides and glides. Now, if I want him to stop, I press the stop button. The other thing that needs to happen is I need to tell him when to do the action. And most of the times you want it to happen as soon as you press the button. In this case, that's exactly what I want to do. So whenever the green arrow or the green flag is clicked, it will automatically start it. Now, there are other things that you can do. For example, you can program it to do its action when the person presses a specific key. So these are those moments when your students are programming, let's say they want a student to press a specific letter before they're going to get an answer, or they want to have something do an action when the person presses an up arrow or down arrow. Okay, this is where your older kids get into the more complicated parts of the coding. All right, so now I've got my dude, and he is going to move forever and ever. He's going to move forever and ever until I press stop. All right, now I'm going to show you how to create a character who changes its costume. So we're going to get another character. I'm going to go into people. And let's see, I like, how about juvie hip hop? All right, now, right now, as you can see, she's got a bunch of costumes. I want her to start this way, and I want to make her smaller. So I'm going to make her smaller. Oops. A little bit smaller. I'm not sure what. Okay. So now that she is small, all I want to do for her is change between her different costumes or her different poses. So we go under looks, and looks is where we control talking and where we control costumes. Okay, so for her, all I want to do is change her costume, okay, over and over again. Now, I do not, if you want specifically to switch to a costume, you can choose this. If, like, say you only want to use 2 of those poses, you can choose which one you want. But I want her to switch back and forth between each of the costumes. Now, let's say I want to do this forever. I'm going to click that. Look what happens. And that is way too fast. All right, so this is where we need to make sure that we put in that wait 1 second. And for me, now it's too slow. So I want to make it 0.5 seconds. So now it's just about the right speed. And then of course we put on this right here. And there we go. And she's all set to go. That's all you have to do to change costume. Pretty easy. All right. Now, I also want her to talk though. And here you can, they can think for a specific amount of time. They can say something. They can say it continuous, or they can say it for a specific amount of time. I want her to speak for, let's say, about 3 seconds before she gets started. And I want her to say, I like to boogie. Not boogie, boogie. And I'm going to drag it right up here, as I don't want it to be in the forever. So when I click, I like to boogie, and then she will start dancing. And that's it for her. So the last thing I'm going to show you is how to add sound. This is a dance party, and to add a background. So the first thing I want to do is I would like to add a specific sound when the dinosaur glides across the stage. So we're going to go into sound, the sound tab. And what I want is I want to play a specific sound. Now right now there is nothing in the drop down menu because I don't have any sounds here. Now to get sounds, just like sprites, there is a sound library. So you go into your sound library and you can choose different sounds. And I want specifically something glidey, and I love this fairy dust. So I'm going to use this, make sure there's a box around it, click OK, and whatever you click OK on it will go here. And you can get a list of them. You can put, I don't know how many, but you can get a bunch of them here. So we go back into scripts, and now when I pull down, I can see fairy dust. Now I want to put it exactly where he glides, so I'm going to slide it right in here and snap it on there. So now when he glides, he makes the awesome sound. All right, so that's not enough because we need some actual dance music. Now this we're going to create in a separate button set of its own. And we're going to use the play sound until done. And this will allow it to play over and over again until somebody presses stop. Now again, the only thing I have there is fairy dust, and that isn't what I want. So I'm going to go back into my sounds, back into the library, and there's a whole area for music loops. And I really like this dance. So I'm going to click on that, add it to my list of sounds. And when I go back into scripts, click on this and press dance around. Now we need to do a similar thing as we did with everything else because we want it to play the entire time. And I want it to start as soon as everything else starts. And so now the music will play. Now I'm not going to play it yet because we want to add a background. So I'm going to go into background. This is where you find your backdrops, and just like characters and sounds, there is a library. There are themes. There's all different kinds of scenes, and there's even X and Y axis down here that students can use when practicing. But as you can see, many different stages, lots of opportunities to do different things. I particularly want this spotlight stage. Make sure the box is around it and click OK. And now you'll have different, backdrops. And students can switch between backdrops as well during a specific scene. And that's something I bet they would have fun figuring out how to do. So now I have my backdrop and I have Juvie on her specific area. So now we're going to start the dance party. Ready? And as you can see, it will continue to do it as long as it's going until you press stop. Now, when you're finished with whatever project you do, there's an area up here that will say share project. I've already shared mine, so I just want to look at the project page. And I've given you a link to this as well, so that when you create your dance party, if you want, you can simply add it to my dance party instead of creating one of your very own, or your students can do the same thing. and they will see this exact thing, and then they can see inside so that they can add their very own. And each one of your students could create their own on this specific page. So you could have, 10 to 15 different dance parties that look like this with a different character for each student. All right, let's review what we've learned today. Remember that computational thinking is an important set of skills that students can use to help solve open-ended, multiple-step problems. They learn decomposition, pattern recognition, abstraction, and algorithm design, which leads to many other skills and characteristics that allow students to be more efficient problem solvers. Computational thinking can be learned in many different ways, but coding and programming have been found to be very efficient. Scratch is a program that allows students to code animations through the use of buttons instead of long pieces of code, and it allows them to practice the steps of computational thinking. And again, Scratch gives students the ability to learn and practice the steps of computational thinking. And we also learned that Scratch can be used in many different areas of curriculum, from social studies to science to math to literature to music and art and just simply being creative. Now it's your turn to really play, and your assignment is to go to Scratch, create an account, and make your very own dance party to take to your classroom. It can be as simple or as complicated as you need it to be or you want it to be. You can create a brand new one, or you can add an animation to a pre-existing one. The link to mine is located in the file links below the video. All you have to do is open the inside. Okay, when you see inside, it will take you directly to the create page, and all you'll have to do is add a new sprite and program it to do whatever you want it to do. It can simply to be moved back and forth. It could be whatever you want to do, play around with it. And then I want you to take it a step further and teach your students how to use Scratch and have them add a dancing sprite to your own dance party. I would suggest having them start there, or teach them a few basics and just let them play around. Getting their hands dirty and working through the problem-solving steps is the best way to get your students thinking computationally. So you want to give them ample time to play around like I am giving you as well. I hope you enjoyed this tutorial and that you learned something new today. Have fun and check out some of the articles to learn more about computational thinking and Scratch. And here are the resources. All of the links are located below the video, along with a link to this PowerPoint with all of my notes, and the links to Scratch and Scratch for Educators.